Hello, my name is Jürgen Niklas-Franken. I'm a German-based computer programmer and have more than 40 years of experience in this field. Current machines have three crucial disadvantages. First, they are sequential in a sense, so one step has to be performed after the other. And a lot of engineering effort has to be put into enabling a certain kind of parallelity. Second, the basic model of these machines is global, so global memory access is a basic operation. And a lot of engineering effort again has to be put to enable locality, for example in the form of caches. And third, these machines are based on the model of Turing machines, and this model is not really an approach to construct or helpful in constructing correct, safe and secure systems. First, our new computer is built on a different logic that enables thousands, 10,000 and 100,000 operations in parallel. Second, all computations happen in a local context. So the parallelity means that we can reach high speed. The locality means that we can switch off parts of the processor which are unused, so that we can construct processors which are much more energy efficient. And third, the model that we built on is called lambda calculus and combinatory logic. And this model leads to a way to construct safe and secure software, which is difficult in the model of Turing machines. The motivation arose when I understood that computers we use are special kind of machines that are result from a certain history. So von Neumann was a crucial constructor of this kind of machines, and he took ideas from Alan Turing. But at the same time, Alan Turing was constructing a new computer, but died too early. So if Alan Turing would have succeeded, he might have constructed a computer more in the lines of what we have in mind. So over a long history of 50 years, a lot of variations and optimizations to the principle of von Neumann was applied to get us to the powerful machines we are using today. Especially the quick progress in hardware technology prevented the thought on a basic different architecture. So the basic motivation arose from the understanding that current machines are just an accident of history. Massimult currently exists as a software prototype. The first commit in this repository is from 17th April 2018, so 4 years ago. In this time we have written about 15,000 lines of IDRIS code and 6,000 lines of C and CUDA code. The system consists of a compiler and interpreter for a functional machine language we call lambda-m, and as well we implemented a virtual machine we call Matrima, which runs in parallel on a GPU. Yes, of course. As an example, we take this little program, which computes the first 20 prime numbers, with a sieve of Aristoteles. It is completely self-contained and does not use any library. Note that nothing in this code is added for parallelity. We now start the compiler of this program. And now start the GPU virtual machine. Here we see the loaded program. And now the types that were inferred. Here we see the combinators to which the program is compiled. And this is a representation of the machine code. So now we evaluate the program. And you see, we get the first 20 prime numbers. We see here that it takes 1,750 cycles to compute the results and 2,828 cells as storage. In average, 42 operations happen in parallel. This is already quite impressive compared to conventional chips, where it is difficult to perform 3 or 4 operations in parallel. Now we use a compiler with recombinators. We see that the compiled result looks different. We evaluate it and get the same result, but this time we only use 395 cycles, which is 4.5 times quicker. It uses less storage and has a parallelity of, in average, almost 75 operations in parallel. So in short, we are on our way to a breakthrough in combinator graph reduction. We see that we are developing a technology which soon can replace a lot of what is currently used in computer technology. We are about to open source our project to speed up advanced progress in the project. And our company would live from building tools for the tool makers, from selling licenses for special parts, and doing consulting.